Our moderator for this panel is Heatherly Bucher, the Director of Strategic Alliances at Arena. She has led product and customer marketing there and knows what it takes to connect strategy with execution. Please welcome Heatherly and the rest of the panel. Woohoo!
It's fabulous to be here. I get to moderate the first panel of the day. Super excited to be at the conference and with Zach and Tony. So I'm going to kick off a really short intro of them. They probably don't need a lot of introduction, and then we're just going to jump into conversation. Zach is the VP of Hardware at Backbone. And when we were preparing last week for the conference, I wrote down what you said about Backbone because I loved it. So Backbone's goal is for gaming what Netflix did for movies and Spotify for music. Zach previously worked as an engineer at Apple and Formlabs, and Zach is also a big proponent of 3D printing. Tony is the CEO and founder of a not yet to be named stealth scalability manufacturing organization. But he's formerly from Archer, a long career at Apple, Sony, and others. And he most recently has been working with eVTOLs and drones, kind of in the frontline spaces that Anna talked about. Anna shared just a minute ago about velocity expectations have really ratcheted up, right? Some might say that first prototype to production in 4 months is a fantasy. Zach, what is considered a fast NPI in 2025?
So it depends on whether you're doing something from scratch, like a Gen 1 product, or something that is an iterative product. I think that 4 to 6 months for an iterative product is definitely possible, and we've done things approaching that, but you have to have some foundation platform that has been de-risked already. For a Gen 1 NPI, which I'm sure many people in the audience have done, that is a whole other thing, right? And I think that 12 months from start to finish, which is what we did on the Backbone Pro, is possible and extremely difficult. And in order to do that, you have to really combine like 3 huge things. It's like TTC. You have to have your team, you have to have your tools, and your culture. We'll talk about that more, probably later. But the biggest challenge with moving at that velocity is how do you make sure that what you're shipping at the end is actually going to work? Because in hardware, there's no do-overs. You're launching the rocket ship into space. You cannot pull it back. And the challenge with that is, like, historically, that breeds like a sense of conservatism, right? We have to go slower, we have to test. Nobody wants to be the one that screwed on the bolt wrong on the rocket engine and then it blows up on TV and it's like your career is probably over. So the biggest challenge for that is how do you not just have the tools like AI, instrumental, or 3D printing, which are incredibly important, but how do you also have the right team and the right culture to make sure that when you do launch that rocket that you built in 12 months, with SpaceX's case, literally that's actually what they do, and make sure that then you don't have it blow up and kill everybody, but instead can then repeat that another 1,000 times. And I think that's why we're all in hardware, is because that level of commitment and challenge is pretty much unparalleled in any other part of tech.
Oh, that's great. Tony, so you work with companies about ramp and production and shrinking those times and in operation. So based on what Zach just shared, what have you seen are the key bottlenecks to production that companies often underestimate, right? That really draw out those ramp schedules, and how do you tell them to do it differently?
Thanks for the question. What's really interesting is that when we're talking about going fast, you have Zach talking about acceleration and operations folks talking about bottlenecks, which is really just avoiding putting on the brakes. And so it's kind of like this, both sides of this coin. In order to ramp fast, it's not so much about stepping on the gas as it is maintaining momentum to not slow things down. But for the NPI side of this, from the R&D side, I think I couldn't agree more with Zach on the how fast can you iterate. And the things that slow us down end up being access to change. And so, especially for smaller companies, if you're a small company, it feels like access to an SMT line can either be 3 months, or later on tomorrow you'll get a new board built. Or access to testing, flight testing, if you're building a drone, can be many months. And so if you are waiting for months to test your product, there's no way you get what Zach's asking for. So this all-in-one type of solution is really important for the hypersonic scale. And so, and I think that's really the core there, is to protect the momentum of a production line. And I'll give you an example. Would be, don't run DOEs on your main production line. That is a great way to decelerate production. And so how do you avoid that? Well, don't bring a bunch of untested changes to the line, or if you have a production line, have another area where you're doing a prototype or something quick. And so I think you want to protect against the brakes being pumped.
Oh, that's good. That's great. So we're supposed to talk about speed, according to Anna. So speed comes at cost, though, or can come at cost, right? The more rapid everyone's working, you can introduce defects, cost overruns, supplier issues, definitely communication issues, miscommunications. And so there's this idea that urgency equals recklessness, right? Or can create recklessness. And what have you guys found about that kind of equation? Does urgency always have to equal recklessness, or what are the guardrails you can put in place to make sure that your team works urgent, right? And you speed up, but you don't get into these situations of recklessness. And I'm going to toss it to you first, Zach, because last week we talked, and hopefully you'll remember, you had an equation to share having to do with this.
Here we go.
That I liked. So, going to ask the engineer for an equation.
I got a slide for it. I think the question was basically, how do you move fast without taking risks? Perhaps, something like that. Okay, so the fundamental hardware equation is that risk is inversely proportional to time. And you could just write this out, right? Like risk equals 1 over time. And then you can throw in 2 coefficients, right? We're all engineers here, so we love our equations, right? So little t times time, little r times risk, or times, So the point is, those 2 coefficients encompass everything that we typically think of as being important to, some process, right? How much money you have, how good your team is, even your culture. Those all go into the rate, the exchange ratio that you can trade risk for time. And where I've seen, some of these startups that I've worked for that are otherwise amazing run into trouble is they fundamentally don't understand that you will always be trading risk for time. Now, the best companies in the world, companies like Apple, companies like SpaceX that have mastered this equation, they can trade that risk for time at a really, really good exchange ratio, right? But at the end of the day, you cannot account for everything. And so when you're asking how do you, go between recklessness and urgency, speed is the most important thing because that is what lets you have the most number of iterations. Those iterations are your currency. They can be spent on everything from, for example, at Backbone, industrial design prototypes, ergonomic prototypes, engineering prototypes, or even doing an entire production run for a build with 2 Fuse 1 Formlabs 3D printers, which is happening right now at Backbone. We're making over 60 units that we're shipping to China because we can do it faster here in the United States than they can based on this process. But at the end of the day, you are always going to take more risk if you want to reduce your time. And the question is, how do you set up your team, your talent, and your culture so that you can make that trade in a smart way, and then over the long run, have enough swings at bat where you can be successful?
Tony, I have to. We're going to go a little off script. We didn't talk. What do you think about that equation, and if you apply it to operations?
So the best thing about what Zach said was iterations is currency. And if you can do iteration faster, you're winning. And back in the day when we were introducing new product introduction processes, you would go and build a few hundred units, and then you take them back and you validate them, and then 6 weeks later, you might come out and try it again, 12 weeks later. And now you can build a few units and test it, and then iterate, and then iterate, and then iterate. And in the course of 5 days, you've had 4 builds. And so that is absolutely the currency. The risk part of it And the comment about urgency, if a company comes to me and says, we lack urgency, I'm running the other direction, right? It is always the right answer to have urgency and constraint. And so I would say the constraint part is choosing the source of urgency. And I'll tell you my favorite source of urgency, Christmas. It's so pure. December 25th, the schedule never slips. And you know what you have to do. All the mature leaders know the trade-offs of volume and quality and safety. And so you basically make all the trade-offs right when you have a team that has a pure urgency. My least favorite, earnings announcements. We need to show progress, or end of quarter. I've had people, we load up all the equipment into sea containers and move them out back so we get better numbers. These types of fictions, there's no such thing as semi-fiction. These types of fictions are not such great use of our time. And so when urgency is driving a reckless pursuit of a unreal goal, something for theater, something for progress, something for demonstration of what you're capable as a company, that's the one I feel like is really a dangerous thing to do. But when you're just trying to solve a problem, when you're trying to get a drone out in the field, it's always a great thing, and with constraint.
So I actually have a question for you there, which is, what do you think drives the people to move the shipping containers to the back? What drives them to try to act like they have made more progress under that urgency, right? And maybe what are the differences between the companies that have the urgency, but then go and are smarter and go do more testing, or are able to actually produce more progress, and the ones that say just stuff the sales channels and say that we made more this year than we did last year?
I'm not dismissing at all earnings announcements as critical, right? Your lifeblood is the market, especially if you're a publicly traded company. And if you're a small company, your lifeblood is like, you got a burn rate. And so these board meetings can be incredibly important. So I don't mean to dismiss them at all as not important, but they're just not as pure. And so you can do things that are wildly setting you back on your iteration and your design and your development and your ramp, so that you meet this short-term need. And so that creates conflict in the organization. And so there's another example, different company. The first one was a Japanese company I worked for. The second one was an American company, very large one. And there they put the stuff in the sea containers and they would ship it to across country. And then over the course of the quarter, they would arrive at the wrong address. And they go, oh, our bad, and send it back. So that way that only the people making that decision of the address knew about the fiction. Everyone else thought it was good business. But there's no such thing as semi-fiction. So I would say the driving force is real in the progress you have to show, and the milestones you have to show. Burn rates. You run fast until you run out of money, then you fold. And so that's what I feel like for the smaller companies. And for the bigger companies, same things. We do silly things.
No, I think it goes back to your culture part too, right? I thought it was interesting your comment about recklessness that drives urgency, right? Kind of the backwards, that you run from that, right? If a company wants to work with you, but it's their recklessness that's driving the urgency, right? Let's shift gears a little bit and talk about practices, tools, design architectures, operation architectures. Zach, what have you found, engineering practices, tools, design architectures, that move the needle most when you do need to compress NPI schedules? What are your kind of go-to things with your team to get this done?
So I think starting with the one that everybody thinks about, which is tools. So for us, it's, again, how do you iterate faster? How do you increase your speed? So coming from Formlabs, where I spent some of my early career, we had literally, so that's a 3D printing manufacturer for those of us who don't know, but at scale. They've made more 3D printers basically at high volume, high quality 3D printers than anybody else in the world. When you are designing a product and you have 300 top of the line 3D printers in your company with a team of 300 people, the way that you think about design and iteration is fundamentally different, right? It's like, before it would be like maybe you take 2 or 3 weeks to get a part machined, and then you do a test, and you better make sure the test is correct because you just spent $3,000 on this part. Well, instead, you should print that part And back then, it was within 24 hours you'd have an answer. Now, with the Form 4, it's within 4 hours. We actually have an engineer, there's this story at Backbone where he actually came from Neuralink, where a lot of my friends are. He developed a new antenna architecture. And basically, the guy did it for his first time. He didn't have that experience, and it was not going well. And then 2 days before the build, we realized that we had to redesign the whole architecture. So he kicked off 3 different iterations on one 3D printer, then had another design space, an idea set. He kicked off another 3 on the second printer. By the time that was ready, the first ones were done, because it's Form 4, it's 4 hours end to end. He went and tested those in 20 minutes. When he did the tests, he knew that pathway of design wasn't going to work. By then, he had the second printer ready to go. He tested those. And so he was basically just dual wielding these 2, radically new pieces of technology. And in one day, the guy went through 16 iterations. And he basically swept through a massive phase space of design. And he found 2 iterations that worked, refined those overnight, did a bigger print, and then tested them at a larger scale. And then basically within 2 days, he was like, this is the design, send it, and the build was saved, which, that is the pace, right? That is what these new technologies can do. Now, what's exciting is with AI coming out, a lot of people that I talk to say AI is going to design your next product. And I take, issue with that as a product, person, in addition to an engineer, where it's not going to design the product, but AI is going to let individuals do way more on their own. The best number of people to work on a problem is the smallest number of people. If you think about a team of 10 people designing one thing, how fast they go, then you cut that to 5. Maybe it's twice as fast. You cut that to 2 people, and it's more than twice as fast. It's a nonlinear. If you can go from 2 people to 1 person, now you're not talking at, 16 bits per second, at how slow human communication is. It is the speed of your thought, right? It is how fast one individual person can keep all of this information in their head, have situational awareness, and then come up with that magic solution that you're like, how the hell did this guy or girl figure this out? And the answer is they're exceptional. And that's where the team comes in, right? So if you can combine those things together, and now you have 3D printing and now AI coming out, an individual can actually drive entire sections of a product, or I believe not too long from now, perhaps an entire product on their own. And that kind of culture combined with those tools and teams is what's going to allow the next generation of hardware companies to move 10 times faster than anything that we've seen so far.
That's a very exciting example. And it strikes me, like you said, you have the tools and tools and technology, right? 3D printers, AI, other technologies depending on your industry. The right team, and I think I would point out the culture, and you as a leader, right, have given them both responsibility and freedom, right, to go do those iterations, right? To not slow down. It's kind of this, you have the freedom to go experiment, right? Rapidly experiment and discard all the failures, but find the 2 that succeeded, which I think is the critical cultural part, right? From my perspective, you could have the team and the tools, but if you don't have the right leadership, the right culture that gave that environment to happen, they may not go do 60 iterations today, right? They might be busy trying to ask for permission, for example. Tony, same question. For ramp and production, processes, supply chain strategies, vendor strategies, tooling, there's a lot that goes on in operations and manufacturing. What makes the difference, though, in compressing ramp time?
Yeah, I always like to talk about the momentum and the bottlenecks, but I'm compelled by Zach's comments. It's interesting because I'm just listening for the first time with all of you, and I'm kind of going, is one person the fastest? And I was realizing, you're probably fast. I'm never as fast as if I have somebody else with me. I don't take a bath without rubber ducks, So I'm a social creature, and I'm not a fan of working from home so much. And I feel like that might slow us down a little bit, although sometimes you have to. And I love this notion of how fast things are happening in Ukraine right now. The work we do with drones there, they've got it. They've got the speed to market nailed out of desperation, out of necessity. They don't have the quality that's in there. And so we still, as we bring that type of idea to innovation here, we need to put the quality moats in place to protect our customers. But I think if I were playing forward what Zach said and taking this defense architecture and moving it in, the way I think about this is we need to think about not systems and products as the thing you're building. If you want to do something in one day, a new antenna, you want to design that antenna so that it can be used by 5 different systems. And that modularity is really helpful. And so, really, like in the drone market, sometimes we think of that as, drones are not really a product anymore. They're like cupcakes. The real product is the bakery. And so you really want to have a system that can, what was the word that Anna said? Co-opetition?
Co-opetition.
But basically the modularity is really key there, right? Where I want everybody in Silicon Valley making technology, and I don't want you to have to spend time trying to make a drone. That's silly. Just keep doing what you do it as fast as you can, do it in one day. And so they're at the forefront of where it's needed. They're able to produce it with the flight testing and just run fast, take down a new thing. If today's fiber optics, that's great, we'll take that and build that in. And so I think allowing the community to build technology instead of systems is gonna really be pretty fast for us.
So it sounds like one of your points here, which is a great one, is like, you can't just design for the problem that you're facing right now, right? You're trying to like create a generalized solution or have the investment of time and resources that you put into that initial development be able to have long-term returns across multiple systems or across even a manufacturing process that can then get either scaled up or down or given or shared with other people or companies, which then, like, if you integrate under the curve, that amount of value is way more than the first thing that you were trying to do, which might be like designing the rotor blade for this one drone that's going to come out this year for some specific reason. Is that correct?
Let me think about that. I think maybe it's the opposite. If I want to solve only specific problems, but I want to solve them generally. And so solving general problems specifically is what everyone's trying to do, and it just goes horribly. And so I'll give you an example is that at one point I was administrating, 400,000 computers for 20 plus years and never had a virus. And anyone in the cyber market would be like, how do I get signed up to that? And the answer is, well, it's easy. If your computer does the same thing every 6 seconds, it's pretty easy to understand when it's doing anything other than what it's supposed to do for every 6 seconds. And so you're like, well, that's a specific problem. You're like, exactly. And so you have a specific problem, you can solve it in a general way that's applicable to other things. And so if you've got a specific problem you're trying to solve and you design the world's best antenna, fantastic. Solve it in a modular, general way. And that way it can be integrated with other people.
Yeah.
So I think we're saying the same thing.
Yeah. The point is, it's like the only way you're going to, hardware companies especially, but basically everybody that's maybe not an AI company today, as Anna's saying, like it's getting more and more challenging. Everybody wants more output, less investment. So it's like everything that you do cannot just be the thing. It has to be the thing plus the next 15 things, and you're building like a platform, like the jigsaw puzzle, you're filling it in, and then you can keep getting a return on that initial investment, right?
Absolutely, exactly.
I don't even have a comment to follow on that because it was so great. But I agree. I think that this ability to approach problems with a broader context, right, is of applicability is incredibly important in every discipline, right? Particularly today with just the rapidity of how fast we're moving and how many things are changing. We got into a bit of a philosophical discussion last week when we were preparing for the panel. So, and I want to just have that conversation because this is all about acceleration. This panel is all about acceleration, ramping, shortening times, innovation. But then we started talking about you have these pressures to ramp, accelerate, innovate. In your case, in your example, it could be because we want to show the market or our shareholders something about how we're responding to that pressure. But how do you know when you shouldn't do this, when you should pass on the pressure to ramp, accelerate, innovate because it's not right for your team, your company right now. How do you know when not to do it?
Take this one first.
Okay.
Or what are some examples of when not to do it? Maybe.
Yeah. So when do we want to slow down or change the instinctive course to sprint forward? It's hard to know, but I'll say this. As you ramp and scale, you need to learn when it's time to solve the problems you do not have. And who solves problems they don't have? That sounds counterintuitive, but risk at scale is certainty. Unlikely things happen when you do it a lot. And so you're really trying to build out that moat of, it's not that expensive to make a strategic plan for how to solve the problems you don't yet have. And then you build moats around to protect your customers from the risks you're taking. And so if you're gonna risk bad parts in, you're gonna tank your factory and your yields, and that may be exactly what you should do. But you wanna protect your customers from that. So you need that moat of protection for safety and quality of your customers, and then you can take those risks internally. And when you have that strategic plan, I can answer the question. When you know where you're going, and you know that gold-plated shit that other people are doing, you can't afford to do right now, but you know where you're going. When the decision you're making is taking you 2 steps backwards, now's a good time to think about going with the plan to solve the problem you don't have yet. So it's an opportunistic moment to innovate and move forward where you know you need to go. So I think a strategic plan for solving the problems you don't yet have is a good thing that we should all try and do.
My turn.
Your turn. What do you think?
Go for it. I'm thinking about a lot of things. That was actually really interesting, Tony, with the moat, because you're absolutely right, which is like, look, the customers don't want to have your risk. That's for you, right? Like that gives them money in your pocket, so you got to find a way to protect them. And I think that's something that is really important for me and the team at Backbone and the other teams that I've worked on is, again, this word culture, right? Which is like, what does that even mean? The answer is it's the set of rules and guidelines that gives a shared understanding for everybody on your team to follow so that you don't need management telling you what to do. You don't need to have a million double checks and other ways to make sure that like your moat is solid, right? And when we look at like these tools that are coming out, I think that a lot of people think about the tools as the thing, but really it's like, how do you have the right team with that culture to allow people to take risks? Fear is the ultimate mind killer, right? It is the thing that stops everybody from trying something that will actually give you a competitive edge. And I think the question for like everybody here is, how do you have a company or a team of people that can take risks without having fear? Like, how do we have the courage to do that? And when I was preparing for a different talk that Brandon, I had some VP of SAR on, was hosting, I thought back to the cave people, right? Like these are like a Neolithic axe handle. There was a guy in a cave 200,000 years ago, right? That was like napping like a tool, right? Like right before, like this is like us. And it's like, then you come forward to like 200 years ago, and you could think of like, Remington, right? Like mass production. And now, we have like the iPhone, right? Like this is our axe, right? This is our tool. And that is a legacy of hardware development that everybody in this room is a part of. Right? We right now are the guy in the cave. It's just that we're sitting in, an aircraft carrier, right? It's a little bit different. But we are still bringing that same spirit of innovation and risk-taking, right? And where I think we fall is when we start getting too scared to be like, how do we build a better axe? How do we go and try something completely new like mass production? Or in the case of like the people that 80 years ago came together and built this insane machine that we're in, they didn't have CAD, they didn't have AI, they didn't have 3D printers. What they had was a purpose, they had a culture that was to take risks and make this thing get out the door because it mattered, and they were willing to do that without fear. And so the question is, how do you build your teams and your leadership such that you don't have fear? Because if you don't have fear, then you have a huge advantage over everybody else that is scared.
That's almost a perfect ending. And I may let you just use that for our wrap-up question, or you can share something else. So we're trying to stay on time. We started late, so one wrap-up question. You can find Tony and Zach today to talk to them directly, right? We don't have time to take questions from the audience. So our wrap-up question is, someone in our audience today, they want to go back tomorrow and move their company significantly faster. What's the one thing, the one change you would tell them to tackle tomorrow to start moving faster? Tony?
That's an unfair question.
Anna made that question, not me. So.
Yeah, I'm watching her. So as I look across all of the things and specific problems you have to solve, one thing that helps a lot of those problems is portability. I really think that portability might be a great thing to have, and portability doesn't mean you own your means of production. That could mean that, but it could also mean that you own the platform, or you own the ability to move from a contract manufacturer. So, and if you're building here in California, you know that ends at some scale, right? And if you're building somewhere else in the United States and you pretend it's dual use, but when you're selling drones to Walmart, those are coming out of Asia. And so, or you're saying, hey, I want to sell this device to Canada and they need it made there. How are you going to do this? Is your company going to pop up 5 factories in every country? Are you going to have a distributed network of factories? Are you thinking that a contract manufacturer in China is going to magically move that into India? The answer is that's all going to go horribly wrong. And so if you want to deal with all the things that Anna was talking about, the geopolitical concerns, the tariffs, the rapid prototyping, the resilience, you're going to need some portability in your factory platform, your solutions. And so I think I would think portable is the way I would take it to solve as many of the problems as I could, address.
Portability. Zach, what's the one change you would recommend they do tomorrow?
The honest answer is take a hard look at your entire company and your team and yourself, and just write down all of the assumptions that you're making. Like, question everything, right? I mean, we're living in an unprecedented time right now for many different reasons. And we're privileged to be able to be in that time with this level of technological development. I mean, even instrumental, right? This incredible technology that's automated inspection, where you can have a computer basically, do the work of like dozens of people that would make mistakes and have all these insights. I mean, that didn't exist 5 years ago, right? Not in the way it does now. And so, it's so much easier to just make a safe bet, because nobody gets fired for making safe bets, right? Nobody gets fired for saving money or saying we're going to do something that's going to be like a little bit better and the customers like it, right? So the biggest thing I would say is like, don't be afraid to take those risks. And it's like, there's so much opportunity in the world right now that, like, even if it doesn't work out at your current company, maybe you get fired, something happens, there's always going to be somebody else out there who says, I want that person who was willing to do something different. And then maybe you'll find out that that company's going to move 10 times faster than the one that didn't do the things that you wanted to try out.
Brilliant. I love it. Thank you all for joining our panel. Find Tony and Zach today if you want to talk more with them.